Welcome back, guys. In the last video, we had discussed about operators and precedence of operators. We have constantly been using printf and scanf. Not actually scanf, but then we have used printf several times. Printf statement and the scanf statement are used to produce output on the screen and read input that is given by the user. Other than printf and scanf, we have two other methods that we can use for input and output. The first one is getChar and putChar, and the second one is getS and putS. So this getChar method is actually not very dominantly used because it has a limitation, and the limitation is that it reads only one character at a time. That means if you enter a complete string of text, then this getChar will not read anything but the first character, and similarly putChar will also just put the first character on the screen. But then this limitation also comes handy when you want to perform any input or output operations using files. That is file input output, which we shall discuss in later videos. These are actually the prototypes, function prototypes of these methods. So the function prototype of printf is int printf and constant char star format. The star means pointer. Similarly, we have the prototypes of all the other functions as well. Now, gets or getS reads a line from standard input into the buffer pointed by S until either a terminating new line or end of file. So this will keep on reading character until it encounters a new line or it reaches the end of the file. And puts also writes the string on the screen unless it encounters a new line. Next is printf. So this printf method is the most widely used only because it has variety of options to use. For example, you can use printf to print float values, decimal value, integer values, double values, long values, and even strings. But then you cannot do the same thing in getS and putS. In order to use getS and putS to print everything that you want, you will have to perform explicit typecasting again and again. So that is not very programmer friendly, and hence most of the programmers use printf and scanf when it comes to printing and scanning of text. But printf has a limitation, and the limitation is that it will not read white spaces. That means if you have a string that consists of, say, suppose 3 or 5 words, so there will obviously be some space between those words. Now, as soon as this printf will encounter that space, it will ignore the rest of the part. That means it will read only the first word. And in that scenario, printf becomes a hindrance. That's why people use gets when they have to, or getS when they have to read an entire line. Now, another limitation of printf is that when you have to print out a percentage sign, because in printf we use the percentage sign as a format specifier. So in order to print a percentage sign into some string, you'll have to use another percentage sign to indicate that you actually want to print it out. Now let us see it, how we use the various methods. So the first one is getChar. Let us just declare one int. So int c. Now what we do is c is equal to getChar. Done. And now we just print it on to the screen. So we use putChar. gcc input output.c, and to run it we have a.exe. So it's waiting for me to give any input. Let me just write programming in C. Well, you can see the limitation. I had actually entered a complete string, but then the output was only a P. So that was the limitation of getChar and putChar that I was talking about. Now let us create another variable called line. Now I am using the square bracket notation because in C, if we want to read any string, then we have to actually declare an array of characters. What are arrays? We shall discuss it later on. So as of now, just see this format. Now, yes, now you see, what we have done is we just declared one variable called line, which is actually an array of characters. Now we take input using getS, that is getS, and then the parameter as line, because we want to store our input into this line variable. And next we are just putting it onto the screen. That means we are displaying the output using puts. So puts line. Now a.exe. I've compiled the code, I've written the a.exe, and now it's waiting for my input. Say programming in C. Okay, so that was the input that I gave, and I got the corresponding output. Now, speaking of the limitation, say suppose you want to take an integer as input. Then what do? We had an integer int c, and we want to take input for an integer. Let's compile this code. There you go. It shows us a method, error. And what it's saying is passing argument 1 of getS makes pointer from integer without a cast. So its prototype actually wants us to enter a string over here, but then we are entering a integer, and hence it's showing us the error. Now let us see printf. Actually, first we have to scan it. Say scanf ampersand s and line. Now this is the format that you should always note. We want to take the input as a string, and hence I am placing the format specifier as %sign and then s, and I want to store it into this line variable, and hence I have written ampersand line. So this is the format that you use. Your input was, I want to print out a string, and hence %sign s and then line, because that was my variable name. Let's just clear the screen. Now gcc input output.c and a.exe. So it's waiting for my input. Let's say programming in C. There you go. We had actually entered a complete line, but then in the output it's showing just the first word, that is programming. Why? Because it encountered a space out here, and hence it did not just read anything that I entered after the space. Just to clear out your doubts, what I'll do is I'll write it in this manner: programming in C. There you go. It has just printed out the entire thing. So basically the printf function does not read spaces. And if you want to take integer as an input, then what do? You just place %sign d and then ampersand c, because c's are integer. So our input was obviously %sign d and then c. Why d? Because obviously again it's an integer. Now let's compile it. Gcc input output.c and then a.exe. It's waiting for our input, say 100. So your input was 100. So that is about input and output. Now we shall see string formatting in C. As I just told you that printf provides us several options for formatting a string. So let us see that. So first we'll see how to display this %sign. It's pretty simple. I want to display a %sign after this words. So what I have to do is I'll have to write it in this manner: percentage and another percentage. So okay, we can even remove these complications. Let's compile it. A.exe. There you go. Okay, I had already a string over here, your input was, and then it's showing the %sign. So basically, in order to show this %sign, we have to use another %sign over here. Now, few other things that you want that you would like to note is, say I have a string, and inside this I shall store programming. Now I will just print out this line. What happened? Okay, yeah, obviously there should be a char. There you go. That's just a warning, so you can actually ignore it. Doesn't matter. Now what happened is it just printed out the first 5 characters. Our string was this entire word, that is programming. Now because I used this %.5s, it told the compiler that okay, I just want to print out the first 5 characters, and hence 0, 1, 2, 3, 4, or rather total 5, 0 to 4, that is 5. So it printed out 5 characters from this word. Few other things are, if you have an integer, say int c is equal to say 56 percentage 3d, and you want to give this as output. So what it will give is okay, yeah, let me store a dot. There you go. As because I placed this dot over here, it gave me an extra 0 before this 56. So this 3 actually signified that I want to have the output with 3 digits, and hence it printed to me a 3-digit number. Now over here you see there is an extra space. Why is that extra space? Because I did not put any dot over here, and that signified that whatever output should I get, that output must occupy at least 3 spaces. Therefore, the last 2 spaces were occupied by this 56 and the first space was left blank. Similarly, if you have a float, so that actually what I had been doing was precision formatting. Now, the same thing goes for float. If I write percentage dot 3f, it means that at least 3 digits will be printed after the decimal. If I just make it a float and I write it as 56.53 or rather 56.5, and you write 3f, print this c, gcc input output.c a.exe. There you go. Now we have 3 digits after the decimal point. So this 0.3f or .3f signifies that after the decimal I want at least 3 digits to be printed. So that was precision formatting. Now we have conversion specifiers. In this thing what happens is it will just convert your decimal value into scientific format. So we have written our number as say 565678.5356778. If you use this percentage e or percentage capital E or percentage G, then what will happen is it will convert it into your scientific notation. So let's use small e and I print it out. So what you get is, let's clear out the screen. We have gcc input output.c and then a.exe. So there you go. It has converted your input, it has converted your number into scientific notation by just removing those, or rather by placing a decimal point over here and e plus 005. So this e plus 005 basically means 10 to the power 5, and hence your number has got converted into a scientific notation. The only difference between writing small e and capital E is that if I write small e, I'll get a small e over here. If I write capital E, then I'll get a capital E over here. Okay, a.exe. There you go. 5.65 or whatever 786, then capital E we have. So that's the difference between small e and capital E. So that is all for this video. Thank you.